super excited to have this activity today. So we have, so today is very special. So this is part of what we call the Sustainability Blitz. And we have Erin and Jesse here today who prepared this activity for us. So I'm not going to be speaking too much because they're doing everything for us today, and I'm super grateful, thankful for them to be here. And good morning, everyone. I know we also don't have usually synchronous meetings, so I'm super excited to be here with you. So you get to also, we get to interact versus you watching videos of me for once, which is nice. All right, so I will let you get started, and thank you so much for being here, everyone.
Awesome. Thank you, Professor Hein. We are going to be discussing the intersectionality of physics today, kind of the concepts and applications in the energy-water nexus. And I'm Jessie Chadwick, and Erin Kim is also on the call. We're both Climate Corps fellows through the Climate Corps program. So we're excited to get into this lesson with you today, and thank you for having us. Want to go to the next slide here? So today, the objectives of this lesson are to explore and apply physics concepts in the energy system, and to identify similarities among multiple electricity generation technologies and methods, and to understand the relationships between energy and water, and to also establish linkages to the climate, natural ecosystems, and the built environment. Now I'm going to hand it off to Erin to get us into some of the technical stuff.
All right. So I just wanted to start with this question, and we'll help you understand what this really means for yourself and for us and for the rest of the world. But just to start, how do you define sustainability? And while I realize this is a very broad question, if you need some time to think, I can share mine. So for me, I define sustainability as a network effect of relationships where everything affects and will be affected by others. So in the context of this class, the physics class, this could mean that the recent mega droughts, wildfires, heat waves, pandemic, and the associated economic volatility are not happening in isolation, but are related to each other. So in other words, what seems like distinct and unrelated disciplines like physics and biology, geography, etc., are therefore related. So if there are any volunteers that would like to share, please feel free to mute yourself or raise your hand, or put in the chat. And was I on mute? No, I was not.
Yeah, we can hear you. All right, everyone, what do you think?
And if you're not sure what this means to you yet, it's fine. We'll continue to explore as we go further along the slides. You know what? Let's move on. We'll get there. Okay, there you go. All right, so let's sink into what we're here to learn about today. So what is the intersectionality of physics and sustainability? Well, physics is a critical component, or very important component, to understanding the climate change. So the natural laws, specifically the laws of thermodynamics, among others, play a key role in influencing the global warming. So they form the basics of our understanding as to why it's happening, right? And also that means that the solution developed with this in mind will help resolve the climate challenges. So just to put this into context and give you an example of what this means, in a nutshell, global warming occurs because greenhouse gases in the Earth's atmosphere absorb the sun's infrared infrared waves, so that would be the heat energy, right? The sun's heat energy. This increased atmospheric pressure changes the jet streams and the associated air pressure and the precipitation patterns, which are causing the extreme droughts and flood cycles. And then these extreme weather events affect key components of the food system, such as the bees that pollinate the crops for farmers and water availability, and therefore require more energy, water, and labor to fetch those resources for growing food, which then leads to more greenhouse gases and a positive feedback loop and causing continued sea level rise and associated inequities like people losing their homes from flooding, respiratory illnesses, respiratory respiratory illnesses due to toxic gases and particulate matter emitted from energy production, etc. And we'll circle back to this last point at the end, just so that we're able to see the bigger context to really understand why physics matter in sustainability and vice versa. In getting there though, I want everyone to keep these 3 questions in mind, which will guide the rest of our activity today. And hold on to your thoughts because we'll ask you a question on the next slide. So question 1, what concepts in physics help connect energy and water? Question 2, what is the relationship between energy and water to the environment and sustainability? And number 3, how important are energy and water in your community and in your daily life? I'll give everyone 30 seconds just to, ruminate over it, and we'll move on.
And I think some people here have been thinking about these questions already. So if
Okay.
if they want to share things, that would be awesome.
All right. I think we can move on to the next slide. Okay. Yeah. So let's start with this question, number 1. What are some examples of power generation that do not involve water? And feel free to just unmute yourself to share or type it in the chat box. Okay. All right. We have nuclear power, wind energy, solar. Um, yeah. Yeah, that's okay. Let's move on. So, oh, what's going on? All right. Yeah. Yeah. So, I mean, in part, you are correct. Wind energy and solar largely comprise the power generation technologies that do not involve water. Nuclear, on the other hand, we'll cover in a couple slides later because they do involve water, surprisingly. So we have wind turbines here, both in the horizontal axis shown in the middle, as well as the vertical axis on the right. There are also solar panels and roofing tiles on the left, and there were recent developments of solar glazing and windows to harvest the sunlight, which can be used in, architectural applications. These are currently in the research phase though, so you'll likely see these out in the wild sometime, much, much later down the road. I don't know, maybe 15, 20 years, but we'll get there. And next question, what are the others that involve moving water for power generation? This one can be tricky, except for the one obvious one. But yeah, feel free to write down in the chat. And it's all right if you can't think of any, because sometimes it's, I had a, trouble with this question myself a long time ago. All right, so dams converting water, yes. Hydro generator turbines. Got some ideas there, thank you. Moving on up. Yeah, so yeah, you're right. Dams, hydro generators, which are for the most part on the left, right? So on the there are actually quite some variations though. The more obvious and familiar to us are obviously the dams, right? Shown on the lower left, which is the famous Hoover Dam. Above it is another facility that is smaller, that is a smaller interpretation of the dams, which still utilize the same concept to using gravity to funnel the water down into the generator. That said, more recently, there are these other ingenious alternatives invented that harness the ocean currents like waves and tides to generate electricity in concert with changing pressure of fluids like water or air to spin the electric turbines, as shown in the middle and on the right. So yeah, I mean, this stuff is all physics, and that's because as demonstrated in this example, the diagram, the general process of generating electricity with moving water is something like this, where in the case of dams, as you see here, number one, the water is stored as potential energy at a higher altitude. And then number two, it gets carried through a waterway down to a lower altitude via gravity. Number three, and then this kinetic energy of moving water spins the turbines mechanically, as someone has already mentioned. And number four, this is tied to a generator that number five ultimately generates electricity. For tidal or wave generation, obviously this isn't exactly the same, but what the gravity is doing here to move water is done by the difference in pressure, where the process of achieving an equilibrium of water pressure between high and low pressure water spins the turbine. So different idea, but they're essentially achieving the same objective. Um, and if anyone has any questions, feel free to just jump in or type in the chat. So I'm not just babbling the whole time. I don't mind. And moving on, anyway, moving on to the last question. What are some examples of heated water power generation? And someone has already mentioned this, one of the examples before. Okay, maybe this one is a little difficult, and it is surprisingly difficult to grasp because a lot of these processes happen behind the scenes and out of everyone's sight. So it's totally okay. Um, next, oh yeah, there you go. So I think though the most easiest and the familiar to us are probably the ones using fossil fuels on the right, or sorry, on the left, such as natural gas and coal, which we've all grown very familiar with from the headlines on the news and the papers. There is also nuclear in the middle, which typically use uranium, and I can explain why water is involved in this process. Next slide. But in the meantime, there are others that use more of a naturally occurring heat, like geothermal on the lower right, that use water heated by subterranean volcanic formations, as well as the solar thermal on the upper right that concentrates sunlight and its thermal energy using hundreds of mirrors to heat up the water. And actually, if you fly to the East Coast or the Midwest often, you might end up seeing an installation of this in Nevada. I actually, every time I flew back home in Chicago, I saw this every single time. And it's just kind of crazy how you see a bunch of mirrors reflecting light back to this one single point, this white point to heat up water. um, yeah, so feel free to share if you've seen any. Yeah. Uh, anyway, that said though, the general process of generating electricity with heated water is, for the most part, similar to the one we've seen before, but with some tweaks, where number one, the water is fed into a chamber, so it's like a storage, or a place where another process happens. Number two, which then is heated by burning a fuel or by extracting heat from a heat source, not too different from boiling water at home using gas stoves. And then number 3, the water goes through a phase change to expand into a superheated and high pressure gas that gets funneled into a chamber to spin the turbine mechanically. So that's the number 3 process here. And then number 4, this turbine is tied to a generator that ultimately generates electricity. And number 5, the used steam is condensed back into a water tank for storage to begin the cycle again. So really, it's not too different, right? So we just talked about the 2 different ways of generating electricity that involve water, but they do share many similarities. By any chance, if this wasn't clear already, what were those similarities between the moving water and heated water electricity generation? That's a question. And if there are any volunteers, please feel free to speak up or type in the chat. There were quite a lot of overlaps, actually, which someone mentioned before in part. Maybe it might be helpful to just go back to the, oh no. Yeah, maybe this diagram may help you think. So along this process, that is. Okay, we got some responses: solar, water, geosolar, thermal, turbines. Keep going if you like. What time is it? Anyway, sorry if you hear my phone vibrating. Anyway, thank you for all your responses. So, at the end of the day, most of the electricity generation technologies are different manifestations of really just one approach. So the difference in being, mainly the fuel, how it's consumed, transferred, or otherwise changed and disposed, and this is a part that's very similar along most of the energy generation technologies, where a turbine is tied to a generator that is mechanically rotated, which then generates electricity, either alternating current or direct current, depending on the implementation. So, this part, oh wait, do you see my cursor? Anyway, this part with the rotor, the rotor shaft and the stator, this part is really the part that's generating electricity, right? And was consistent throughout both technologies at the end, towards the end, steps 3 to 5, I believe it was. Oh, great, thank you. Yeah, so actually this concept or this approach to generating electricity is basically how your car is able to keep its lights on and let you avoid having to jump start it every single time you try to start the car, because there is a little generator under the hood called the alternator, which works in the same way to generate electricity and keep the battery charged. So you know how when the engine is rotating and combusting gas, there's a little belt that ties it to another turbine next to the engine that does the same thing. It's actually pretty fascinating how much power it can generate despite being so small. But that said, the fuel used, its consumption processes as we have covered here, and their byproducts are really the ways in which the physics is related to other aspects of the built environment, the natural ecosystem and its inhabitants through water and energy. So as we have alluded to earlier, way earlier, let's circle back to why we're talking about sustainability in physics class, why we believe it's important, and what this means for everyone, including myself, Emily, Jesse, and all of you, in the context of equity. So now I will hand the reins over to Jesse. Thank you.
Thanks, Erin, for all that information. It looks like is the video not on the slides? Oh, it's loading. Okay. So like he said, we're going to start thinking about how energy equity and energy production can impact humans and our environment. So I was wanting to start with kind of an introductory clip from this TED Talk, if we can get the video to work, to give some background information for those who don't know much about energy equity.
And I'm going to attempt to share the audio. This is my first time doing this, but we can share the link to the video straight onto the chat too. Let's see.
Yeah, I'll share that anyways, because this
Uh-oh.
is only a 4-minute clip of it. So
Okay, I cannot play the video for some reason, so please, I'll just put the link on the chat. Oh, thank you.
oh.
They're both
Okay,
the same link.
cool. Yeah, so you can maybe watch this video in your own time afterwards, because I had narrowed it down to kind of a 3-minute clip between 1 minute and 4 minutes on the video. But there's a much longer talk if you're interested in it. And we can just kind of get into our activity. In the video, this woman discusses how energy is inequitable currently in the US, and how that's both a cost issue and a location issue. So where power plants are currently is usually in lower income areas and are usually surrounded by communities of color as well. And that different communities of color use a certain percentage of their household income to be able to pay their energy bills. And many of them have to sacrifice other things just to be able to pay for electricity. So moving on to our activity, I can share a link in the chat. We created kind of a worksheet for you to work independently to kind of see how energy equity relates to your own community, and to gain a better understanding of where your energy comes from as well. So I think this link gives you viewing permission, so you can make a copy of it if you would like to take notes as you go through the activity. And we'll work through it individually, and we can come back together in about 10 minutes to discuss. If you have any questions, feel free to put them in the chat or unmute during that time, and I can try to answer them. But there's a couple links in there to some energy dashboards where you'll get to look at different data and how that applies to your communities.
Would you like, if you want, I could create some breakout rooms, or do we want to let people work?
If that's easy. I hadn't done that on Zoom before, so
I am happy to do it.
Okay,
For you,
yeah.
but maybe everyone you can let us know if you'd rather. We can create maybe 2 or 3 breakout rooms, maybe 2, and then. So if you'd rather that, and give you a few minutes there to either work on it by yourself, or maybe you can chat with others. And maybe give me a thumbs up if that's what you'd prefer, or thumbs down if you'd rather not. All right, I have so far, I see, okay. All right, so let's do it, and I will create 2, and you'll be assigned automatically. How much time should we?
Probably like 10 minutes, I think.
All right, so let's do 10 minutes. So it's about, all right, so it's 10:27, so we'll be back around 10:37.
Perfect.
All right, so I will go ahead and create and open the rooms. All right. I will also pause the recording.
Through that activity, and what understandings can be drawn from that data, or what are some ways that power generation can impact our environment or our communities? Feel free to share in the chat or unmute if you're comfortable. Oh yeah, Aaron.
Hi, I thought that having renewable energy or having that circumstance in life, it would kind of change the current supply. And I saw that in the graphs of current supply where renewable energy is the top. And if that was not the case, I believe natural gases would be the top, maybe about in the 90s. And that would kind of change the environment where how as in that time, there's a lot of big cloud and the environment wasn't very sustainable, even though now we can see that it's changing, but we need to be at a point where it needs to be totally 100% renewable. Maybe nuclear also could be another stance on that. But I believe, yeah, renewable energy is the top of the stance.
Yeah, it's a great observation. Thank you for sharing. Does anyone have any takeaways from that was the California dashboard, the California ISO dashboard. Does anyone have takeaways from the power maps that you looked at of the power plants and the demographics surrounding them? Were you guys able to change the radius in miles on that dashboard? And what did you see change when you changed that? Okay, if no one's comfortable with sharing, I can kind of talk through some of my key takeaways through going through this as well. In the activity, I had you go through and in the drop-down menu under disadvantaged community over the statewide demographic view, selecting yes shows disadvantaged communities, and you can also see the locations of those power plants. And when I was looking through the map, I actually saw a very strong correlation between the two. Wherever there was a power plant, it was usually within a disadvantaged community. And also, as you go through the specific plant demographic view and you change the radius, as you get further out away from the plant, it usually the percentage of the population that are people of color decreases. And it's also interesting to look at the median income and the percentage of people below the poverty line. So we can get into also some of the environmental impacts. And so our current energy system impacts our environment in so many ways. And one of the main impacts of energy production that we've already kind of discussed that's contributing to climate change is the pollutants and greenhouse gas emissions produced in the process. And also many of these processes, as we discussed, require water, which is already a scarce resource, as many of you, I'm sure, know, living in California. And like in this picture, many of the power plants are actually located near bodies of water, and this can contribute to particulate and temperature pollution in that body of water. And some of the methods also create hazardous waste as a byproduct that then needs to be disposed of properly. And like any industrial production, power plants can take up a lot of space and require that land to produce power, which can no longer be used for anything else. And this can also create an impact on the surrounding habitat and ecosystem by disrupting that area.
And I want to add very quickly that there are actually a ton of legislations and other initiatives by the federal, state, and the local governments to promote clean energy and mitigating these impacts, including the Senate Bill 350 to double the energy efficiency savings of all end uses by 2030. So this will be like using a microwave at your house, or turning on the lights, as well as the Senate Bill 100, or SB 100 for short, which sets a goal of achieving complete decarbonization of the electricity grid by 2045. And these are both in California. So there are also Department of Energy. So Department of Energy is also pursuing research and development projects such as the Grid Interactive Efficient Buildings, or GEBs, or GABs for short, to reduce total energy use and increase renewables adoption, much of which actually is studied at the Lawrence Berkeley National Lab at the East Bay, if you ever had a chance to go there or have been there before. And Jesse?
Yeah, thanks, Erin, for sharing those. And as you hopefully saw through our activity, many power plants are located in those disadvantaged communities. And this graph is from the EPA, and it displays the number of plants that are located in or near communities that meet or exceed the 80th percentile nationally for each of these demographics. So this includes low income, people of color, people who have received less than a high school education, people experiencing linguistic isolation, individuals under the age of 5, and individuals over the age of 64. So the EPA also says that the populations that are the most vulnerable to environmental pollution include the poor, elderly, young, and those who already are experiencing poor health, and indigenous populations. So being in close proximity to these power plants can actually increase the possibility of developing heart or lung disease, asthma, bronchitis, and all of these can lead to increased emergency or hospital visits and sometimes premature death. So this means that this pollution from energy production isn't just an environmental issue, it's also a huge public health issue and an environmental justice issue. So the many impacts that we've discussed of energy production on both the environment and our communities are some of the main drivers for change in the energy industry to start switching to those cleaner and renewable methods of energy production. And now I think we have some time if you guys have any questions. If you think of any after the fact, or if anyone who's watching the recording has any, we're also happy to answer them over email.
And actually, there was one thing that I did want to go back and cover again.
Go
Something
for
I
it.
may have brushed over without explaining too much. So on this slide, I was talking about how as compared to dams where the gravity is doing the work of pulling the water from a higher altitude to a lower altitude, I said that tidal and wave electricity generation technologies use the pressure, the equilibrium, the process of achieving an equilibrium between high pressure water and low pressure water, and how that pressure difference causes the turbines to spin. I was referring to this one diagram. So, as you see, when there's a wave, going up, the water will obviously rise, right? and fill this void, and the gas in this chamber, so to speak, will be compressed, right? And that the pressure buildup will push the turbine this way or that way, left or right, and rotating the generator to create electricity. And that's what I really meant to say. So yeah, that's it from me.
Do you know how far? I mean, is it close to? Is it far in the ocean, or is it close to? Because I see there's a photo with like this bridge and there's a car, and I'm just wondering how far into the ocean is this going? Do you know by any chance?
I think it really depends on the context. So
Mhm.
sometimes there's a concern with the systems not being able to withstand all the
Mm.
energy from the waves. So because there's just, there will be too much stress buildup on the structure of the equipment. So sometimes they'll put it closer to the shore, or if they know that they really need a lot, then they'll just put it out really far in the pier, along the pier, I don't know,
Got
like
it.
100 meters.
Got it.
It really depends.
Thank you.
Yep.
So
Thank you
do
for
we
the
have
question.
do we have any questions from the audience? And it could be about, anything from the beginning to the activity.
And actually, one
Mm.
more thing. Aaron had mentioned that there was a lot of natural gas used for power generation during some times of the day, as opposed to using renewables. So this is a technical component, but the reason so much natural gas is used is because it allows very quick ramp up and quick ramp down. So technologies like nuclear, they don't really like to be ramped up and down too much. So they want to stay very consistent, which is the reason why nuclear power generation plants are considered base loads, meaning they are serving the minimum load that's required at every time of the day or any time of the day. Yeah, but natural gas, on the other hand, the gas itself is still pretty cheap despite all the, well, right now it's expensive because of the war in Ukraine and whatnot, and fuels prices are always go up during times of war. But it is much cheaper to operate at a non-consistent rate. So that's the reason why, to fill the gap that renewables aren't able to deliver when we have climate variability. And Aaron asked a question, is there a research paper on a website where your work is going to be uploaded? And a question from Risa, is it possible to produce equipment for renewable energy without adding to our pollution? Good question. Thank you for that question. So the production of solar panels itself require toxic chemicals, which is another not so great part about solar panels, but compared to the amount of energy production potential that they have, um, when comparing it with the amount of chemicals that are being used and having to be disposed of, the benefits clearly outweigh in favor of solar panels. So yeah, there's no free lunch and anything really.
No perfect solutions yet.
Yeah. And yeah, I think nuclear energy can do as it has no bio-waste. Yes. The only caveat is that the disposal of nuclear waste is still a problem. There are technologies being developed where potentially the nuclear waste can be used even further so that their half-life of the radioactive materials are reduced even down to 500 years compared to 50,000 years, which is much more manageable, right? But those are still in the development phases. So, a difficult development. Nonetheless, they are still being made. Is there a main designated spot for nuclear waste? Yeah, so that's the challenge. The federal, actually, the international bodies have been, ruminating over this question for like 50 years. They have a plan, but the cost to bury it like a mile below the surface is so expensive. Just imagine having to make a tunnel and move all that dirt out and dispose it somewhere. Moving dirt is a lot of money. So yeah, money is really the issue here. But thank you for the question.
Yeah, and the conflicts of obviously like nuclear waste is not great to be around. So it's a public health issue as well.
Yeah, especially when we're talking about like Chernobyl, the really old, Soviet era generation technologies, it gets brought up very often because, there's a lot of mismanagement that the Russians have done with the power plant there. And it's an older technology, so there were no safeguards. But the generation 3 and 4 technologies have passive safety technology. So it's relatively safe, but it is a perception issue too. And something I would, even myself, knowing how safe they are, I wouldn't feel comfortable being next to a nuclear power plant, to be honest. Just because, there is that possibility, right? Even though it may be like 0.00001%. Yeah, thank you everyone for the very helpful questions and feedback. And we are very happy to make these materials available. And, just a little plug. I'm not a researcher or anything like that, but I do have a website where you can dig through to look at any resources or relevant articles from a variety of sources on both sides of the political spectrum. I can share that link with Emily if you guys like. Yeah, so I mean, that's just that.
Yeah, that'd be great. And I'll make sure to share all of the materials.
All right, thank you, Emily, and thank you, Aaron, for the.
Yeah, thank you so much. This was really, I think it's, well, it was great because there was a lot of physics, but also, a lot of things to be thinking about. And I think we don't relate the physics topics to, like in this case, sustainability and consequences, like, and social justice. And so it was really great to see all of this in an hour all together. And so that was and I think, right, in the choices that we make every day, we this week is Earth Day. um those are things that we should definitely think about, where our energy comes from, how much we use, and what we could do differently. So thank you both so much. I know it was a lot of work preparing all of this. And there's still a lot of information still packed, right, in the activity, because you can dig through all of this data. And if something comes up later and you want to look into that, you have the resources. So thank you both so much, and thank you for everyone for coming and for participating, asking questions. Super appreciate that.
Yeah, thank you everyone for participating, and thank you, Professor Hein, for having us.
It was my pleasure to have you, and yeah, thank you so much for everything. I see a link in the, sorry, I have so many things. It's interesting because EDF is also electricity of France. So I was like, oh, it's probably got a but yeah, these are great resources. And I know some of you here are working on your projects, and so you might want to use some of these resources. So all right, thank you so much. I'm going to stop the recording now.